So problem B, it says, I worked all summer to save money for my first semester of college. Then I spent a little money, a little bit each week. These are the records I kept. So it looks like at 2 weeks into the semester, that was how much money was in the account. Then 4 weeks and 6 weeks, and so on and so forth. So let's figure these out. Independent would be time, and being we're dealing with weeks, not minutes or seconds or hours. And then the dependent is money in the savings account. Okay, that's basically all you'd have to put. Okay, questions so far? Seem okay? This is page 179, right? Just making sure I'm on the right page, because boy, I've made errors before. All right, plot the graph on the graph below. So I'll extend mine a little bit. So here I'm going to go time in weeks. And then this is money in the account. All right, so time in weeks, it looks like we go up to 12 weeks. So I think what we could do, this is our x value, our x-axis. So this is our independent. Okay, I'm just labeling a whole bunch of stuff, not that you necessarily need it. And this is our y-axis. And this is the dependent variable. Okay, so independent, dependent are just fancy ways of saying x and y. That's, I mean, and I want to clarify that because there's sometimes they put so much emphasis on calling things independent and dependent, and it's like they don't flip-flop. It's just x and y. That's really all it is. So time in weeks, so I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's take this all the way out. 14, 15, 16, 17, 18, 19, and 20. Okay, so those are all our weeks. Not that our data goes out that far, but we can label it all the way out. It's not a big deal. Okay, so I bet you most of you got that pretty well. And then you get to what should you do with the y-axis? Now, bless you. In the world of science, a lot of times they don't start at 0. Math people like to start at 0. Science likes to start, if it's way out, they usually put a little squiggly line. And math people freak out because of it. Being that I'm certified to teach all math and all science, doesn't bother me one way or the other. Now for these, I think it's important. Please start at 0, 0 in math, and then go from there. So it looks like the most amount of money is $1,750. I don't know. Count by 50s. Yeah, maybe able to get by with 50s. So let's go every other one. Let's count that as 100, 200, 300. Where the middle would be the 50 mark. 400, 500, 600. And this might not work. Nope. See, I chose the wrong, didn't I? All right, so maybe let's count each line as the hundreds because I ran out of space, which that happens. Everyone's week going all right? Got the weekend? Yeehaw. All right, so maybe 100, 200, 300, 400, 500, 600, 700. Yeah, I think this will work a little bit better for us. My hand is getting in the way of stuff. 1100, 12, 13, 14, 15, 16, 17, and then very, very, very tippy top, 1800. All right. So at 2 weeks, Make sure I have that right. 2 weeks is second. Okay, so I count by ones. At week 2, we are at 1750, so roughly here. At week 4, oh, that was at week 1. Oh boy, can't take me anywhere. At week 2, we're here. At week 4, 1, 2, 3, 4, we're at 1600. At week 6, 1, 2, 3, 4, 5, 6, we are at 1450. At week 8, we're at 1250. At week 10, 2 more over, we're at 950. And at week 12, 2 more over, we're at 700. Okay. So that's basically what our data looks like. So just by looking at it, we're spending some money. Agree? It looks like it's forming a straight line. So if we kind of estimate a line of best fit, and again, don't connect the dots. Line of best fit just kind of will go through. I'm going to try and start. Let's see. Let's make this. Ooh, I'm going to pick a fun color. I like this pink. I'm going to go with that pink. So I'm kind of going to try and draw the best I can. I might have to adjust this a little bit. So that looks like an okay representation of our line of best fit. Granted, your might look a little different. Just please don't do dot to dot. Don't show it jagged corners where the dots are. Just show it as, up front. And we actually have an activity that I'm going to show you, kind of fascinating how it, to think about money in this situation too. I'll plot the points, write the equation of the line of best fit. Okay, what 2 points would you like to pick? So remember, kind of the rule of thumb, it's not, like engraved in stone, but you want to pick 2 points that are far away from each other, but close to the line. So maybe I'll pick this point here, and I'll pick this point here. I don't know. Those look like they're far enough apart. Don't pick 2 right next to each other because sometimes the slope gets mixed up. But pick them kind of farther away. So I have a couple data points away from each other. So I'll pick the first and the fourth. So if I go forward, so I'm going to pick the first point, 2, 1750. And I picked the 1, 2, 3, 4. Did I pick the 5th point? 1, 2, 3, 4. Yeah, 5th point. Okay. And the 5th point. Now, friends, let me just pause here for a minute. If you chose 2 other points, you're not wrong. Does that make sense? As long as they're from your data. Don't say, hey, I'm going to pick other points that aren't part of my data set. Pick 2 points that are part of your data set. When this comes to a quiz, we'll have you do the line of best fit, and then we'll say, hey, use these 2 points. Because that way, that you would have in the same line of best fit. But right now, you were given the opportunity to pick whatever 2 points you wanted. And let's find our line of best fit. So first thing I'm going to do is I'm going to label x1, y1, x2, y2. And our slope is this. And let's plug in. We called y2 950. We called y1 1750. So minus that, right? And then called this 10, called this 8. Hey, I need your help. On your phone, will you go 950 minus 1750, please, on your calculator? Tell me what you get for the top. On bottom, it's over 2. I know that, because 10 minus 8. What's 950 minus 1750? It's got to be negative. Help me out. Y'all have phones. Negative what? Negative 800? Is that it? Cool. All right. Hey, friends, does it make sense that we have a negative slope looking at our line? Yeah, that means our correlation is negative. If we have a negative slope, then our line will have a negative correlation. That's not a bad thing. It just means we have a negative slope. Okay, then let's go ahead and reduce it. This reduces just to negative 400. And we could put it over 1, or we could just say negative 400. Okay, so that's our slope. Okay, do we feel comfortable with that? All right, let's continue with our line of best fit. So then I'm going to use point slope, which is this equation. So because we already labeled this x1 and y1, okay, I'm going to go ahead and use that again. So I'm going to get y minus 1750. So notice it was a positive 1750. When I plugged it in, it is a subtraction sign. The slope we already found is negative 400. And then we labeled x1 2, so that's going to become a minus 2. Notice the positive 2 becomes a negative 2. Yeah? Wait, hang on. Oh. Thank you. Oh my goodness. All right. Yeah, that should have been a 2, right? And that should have been an 8. And that should have then came out to negative 100. So that's negative 100 there. Oh boy. I'll tell you. Can't take me anywhere. So that changes that. Thank you so much. Oh boy. I made a mistake. I'm sorry. Okay. Does it all now look better? I'm sorry. Thank you for getting that error. Boy. All right. So then I'm going to go ahead and distribute over my parentheses. So I get y minus 1750 equals negative 100x. Negative 100 times negative 2 is positive 200. Do you feel comfortable with that? And then I'm going to add 1750 to both sides. So I'm going to get y equals negative 100x plus 1950. Okay. Is Stirrups math right? It's very possible he's being a ding-dong and making mistakes. Okay. So, hey, what's happening? Who would you like? Me? Adrian? This nice young man right here. Adrian, give me your matches you were playing with. I gave them to you. I'm kidding. Adrian, this is being recorded so you can catch up back up on it. Adios. All right. All right. Does your scatter plot have positive or negative correlation? Was the slope negative? Slope was negative, therefore it has negative correlation. That's all correlation means. Is their slope positive or negative? That's all it means. Okay? So what is the slope? We called the slope, I believe, if we looked at, what was the equation? Y equals negative 100x. What was the rest of it on mine? 1950? Is that what it was? Okay. So this is my equation that we made. My slope is negative 100. It might make sense to put it over 1. Okay? And the reason I'm going to put it over 1 now, not in the equation, but now, is, remember, this is our y value on top. And our y value on top, as far as our graph went, I think we labeled on our graph, we labeled that money. And the x value was weeks. Okay, so this is money. And the x value are weeks. Okay, we good? Seem okay? All right. Explain what the slope means in this context of this problem. We spend, and I'm going to put a word in there, on average, $100 for each 1 week. Okay? So that's basically what our slope says. Now, is it possible we didn't spend anything 1 week and then we spent 200 the following week? That's possible. Okay? So, we're just taking money out. But I will show you something that I think it'll key in some interest here in a few minutes, a little bit more than this will. Okay, so that's basically what we're going to say so far. So we had y equals negative 100x plus 1950. Just double check. Cool. All right, so this is our b value, which is our y-intercept. And you remember I said the y-intercept is a point, so that's 0, 1950. So the x value we said was weeks. The y value is money. Okay, so what is the coordinates of the y-intercept? 0, 1950. And this basically means in the context of this problem, because our data started at week 2, so we started with $1,950 in our account. Okay? Now notice the 1950 is not on our data that's given. We are able to do something called extrapolation. It's outside of our data to figure out if we truly were keeping the same rate of change that we're spending each week or every other week or whatever it is, that we started with $1,950. Seem all right? Okay, so that's what's the y-intercept means in the context. Use our equation to say after 14 weeks. So again, by using what I had, you might again have it a little bit different. How much will I have after 14 weeks? So what should I do with this 14, my friends? Should I plug it in for x or y? What do you think? X, yeah, it's 14 weeks. I'm plugging it in for weeks. So again, this is extrapolation as well because our data set does not go beyond 12 weeks. So we're able to kind of make some predictions of where we would be at. That's negative 1,400 plus 1,950. So if I subtract those from each other, is that 550? So this 550 at the 14th week, we have $550 left in our account. Okay? That's what it means. And again, it's extrapolation because it's outside of our data set. If we're predicting something inside of our data from 2 to 12 weeks, that's called interpolation. It's inside of our data set. All right? Use our equation. Well, our equation was this. And we want to know, use your equation to estimate how many weeks it will take for me to have less than $100. So again, remember, this is weeks, and this is money. So where should we plug that 100 into our equation? For x or y? Y, yeah. So I'm going to go 100 equals negative 100x plus 1950. I'm going to subtract 1950 from both sides. So that gives me negative 1850 on the left equals negative 100x. I believe we divide each side by 100 to get x all by itself. Negative over negative this week is going to mean positive. And so after we have less than 100, how many weeks? That should come out to 18.5 weeks. So after 18.5 weeks, we have below $100. Huh. Okay. Not too tough. Pretty straightforward. But can I have a little fun with y'all? Can we, you won't have to know how to do this, but what I want to show you, this comes up on the graphing calculator. Let me pull the graphing calculator up. I'm still using this deal. Okay, so this is the graphing calculator. This is similar to the one that I have in my cabinet over, I think Mr. Peterson actually borrowed them. Okay, so let's talk money. Can we talk money? You all are relatively young compared to me. I'm going to be 51 in December. Okay? So I'm going to use something called a Tvm Solver. So I'm going to go into my apps. I'm going to go into finance, and I'm going to use the Tvm Solver. Okay. So, friends, there are 12 months in the year. Agreed? You guys are 14, 15, maybe 16. So let's start from age 20 to age 65. So from 20 to 65 is 45 years. Agreed? So I'm going to go times 45. So we're going to make 540 payments. Okay. Now, according to this poster behind me, it basically states that an index fund in a growth portfolio is averaging 9.2%. Okay, and that's over the past many years. Okay, so this is very cheap data. Okay, what an index fund could be. It's not necessarily an individual stock. It might be a mutual fund of some sort. Okay, which is you are putting money for businesses to borrow against and use, and then they pay you back in interest because they borrowed your money. They borrowed money to make something, and then that company made something, and they pay back into the index fund a certain. So let's say a company borrowed $100,000. Well, they're going to put back into the account maybe $120,000 for that loan because they made more money off of that. That's basically what an index fund is. So we're going to start with a previous value of 0, but we are going to choose to put $200 a month into this index fund. Okay? We're going to do payments per year of 12, and cost per year is also going to come out to 12 because we have 12 months. And I wanted to find the future value. Okay, so my future value is going to be alpha solve. If you were to do this, okay, we're talking $200 a month when you start at age 20 and you wait to age 65. You would have $1,586,582.43. Okay? Cut my pencil real quick. Thanks. Oops. 158,658.2.43. Okay? So now I'm going to quit out of this for a moment. How much were we putting in? 200 for 540 months. Friends, this means in this situation that you put $108,000 into this account. Thank you. Okay, so let's think about the interest that you're making. 158,658.2.43. I subtract the 108,000 that I put in. That means that you're making $1,478,582.43 in interest. Would you be willing to drop $108,000 to make that much more money? I'm just, hypothetically, think about what you would want to save. Now, let's take this one step further. Let's go back into my apps. I'm going to go back into my TVM Solver. My stuff should still be there. Yep, it is. All right, so watch this. So, you want a good retirement, yes? This is a very cheap, quick, easy way to do it. Time is on your side because you're young. The people who are old, who say, oh, I'm 55 now, so I'll start saving for retirement, are never going to accrue the interest, the compounded interest that you would accrue if you started saving. Okay? So, we're going to keep our money in this account. So, from 65 to age 90, sound good? 65, what's 90 minus 65? 90 minus 60 is 35, right? Or 30? 25, right? So we're going to now get payments. We're going to use our money to pay us back. So we're going to get 300 payments from age 65 to age 90. Okay, still following me in this adventure? We're keeping it in that 9.2% interest rate because it's still making money. But I'm going to take my $1,586,582.43. We're going to take our future value down to 0. So now we used our $108,000 investment. You still following me on us? Our $108,000 investment when we are 65 years old is $1,586,582. So I'm no longer saving for my retirement. I'm going to draw out my money for me. Okay, to spend. So you have $1,586,582.43 that your money is now going to pay you back. So our future value, FV, we want to 0. So I want to figure out how much of a payment is going to be given to me or to you each month until you're age 90. Does this make sense? Your money worked for you over time and made you an unbelievable amount of money. Okay? So I want to figure out how much they're going to give me. Oops, I don't want that. I want this. Friends, you are going to get $13,532.51 from 1 month after you turn 65 until you hit 90 years old. Now you're like, is that a lot? That's every month. Think about that. Is that a good amount of money each month? Huh? It's too much, but you saved it. It's yours. How cool is this? So think about this. Now, some people kind of have a hard time fathoming what that money is. So 1, can I borrow your pencil again? Thank you. 13532.51. Thank you. So let's put this into context of what this is going to mean. This means 13532.51 times 12 months. Friends, you are now making $162,390.12 every year until you're 90 years old. Okay? Now, here's the hang-up. Here's the big hang-up. All this is the same math we were doing. Okay? Think about that. Do you think you could live on $162,000 a month or a year? Okay, now, so I did this pretty simple. Is $200 a month a lot of money when you're age 20? Think about how much you probably spend at Starbucks each day if you are a Starbucks goer. Or think how much you spend going out to eat each week and multiply that to figure out each month. So $200 is not a large amount of money. Okay? Maybe when I was a kid, that was a lot of money. But think about that. Do you think you would spend all of that $162,390,000 every year? Maybe the first couple of years, you're having a blast. You're like, dude, this is money. I'm getting paid. My money is paying me back now every month until I'm 90. So what you might want to do is, let's say you decide, you know what, I'm probably only going to spend about 100,000 or not even that each year in today's terms. So then you sock away the other money. You can tuck it into your mattress or put it in the safe at home. Because after age 90, if you live on the age of 90, that's pretty incredible. So you could still continue to save money. You're not necessarily going to save all that money. Now, here's the beautiful thing. Let's say you have children. Okay? That money is your money. Now you've turned this into a trust fund for your children. So let's say you pass away before you're age 90. That money goes to your children, or your dog, or your cat, or your best friend until it runs out. Okay? Friends, this math that I just did here is not hard math. It's not hard to fathom. Can I save money for the future? And the hard thing is when you're a teenager, and believe me, I understand. When you're a teenager, it's kind of hard to think, do I really want to worry about when I'm 65, or do I want to live in the now? With the chance, and the very good chance, that you'll make it to age 65, could you imagine living off that kind of money? My friends, this doesn't become where should we go for vacation money. This is not money that you're like, you know what, maybe I feel bad about flying first class. No, you sit up at the front of the plane, you board that plane first, you're in that good cushiony chair that reclines, and they bring you food and sodas and slippers. And you get to travel anywhere. This is a very quick, 45 years quick, but a very easy way, or 35 years quick, a very easy way, 45, excuse me, if I did my math right in my head, I'd be unbelievable. This is a very easy way to be a millionaire when you retire. It's not impossible. Now, things that I did not put into account with this situation. As it grows, yes, there are some weeks that's going to be cruddy. Some months, might even be some years. But I could show you more about stocks and how they work. As long as you don't do the sky has fallen, take all my money out, you're fine. It's the long haul. I mean, friends, I showed you how to become a millionaire in a very simple way. Now, things that I know that are going to happen in life. Let's say at age 20, you start with this $200. You're in college, you go to school, you get out of school, you get a job. Now your job, you actually have more money that you are making, so you can increase your $200 a month to say $300 or $400 or $500 or $1,000 a month. What's that going to do to that end result? It's going to move the decimal place one place to the right. Okay, your $1,586,582 might not be 1 million. It might be 8 or 9 million. It might be 10 million. Think about that. I'm just trying to plant a seed. And so a lot of times students say, Stirrup, you should do that. I am. I've been doing it since I've been 18 years old. Wiggins really does. I mean, Wiggins' wife's an orthodontist. So Wiggins move that decimal, maybe even might move over 1, maybe even 2.
He invested a Tesla stock and an Amazon stock pretty early.
Yeah. Yep. Yeah. No, there's different ways, but I'm just showing you a very simple, nondescript way of doing it. I'm not an individual stock person. I am a mutual fund person. Of my mutual funds, I'm very diversified. I have something called large cap, which is my main one. Those are big corporations. I have mid cap, which are corporations that make about $5 million a year. I have small cap, which are corporations that make about $1 million a year. They all make interest. I have high risk. I have global accounts, which are worldwide businesses. I have local businesses that are Colorado and Arizona local mutual funds. I have mutual funds that deal with the United States. It's very diversified. Figure this. I'm going to be 51. I started this at 18. I didn't start with 200. Okay? But I increased it each year. And my wife was brought up with the same principles. And we continue to invest and continue to invest and continue to invest. Now, I won't show you my portfolio, but when you see me when I'm retired, you're going, how's retirement? Yeah, baby. Stirrup's doing fine. Okay? Yeah, the market, there are dips. If you look up here, okay, this is from 1925 to 2018. So you look at 2008. Oh, yeah, it had a little dip right here. But friends, I started investing in 1989. See how it's a positive slope? Yeah, there was a dip there. But what happened after that dip? It grew again. Okay? Friends, this is just something for you to think about. I'm happy to talk to you about it, how it works. It works in a really good way. So my friends, would you do me a favor? For Monday, would you have page 181? Complete that. It's just questions 1 through 9. It's the same idea. One word problem. Cool? Did you like that? Was that an okay gig?